Hey everybody, this time we got Desmos lesson 2. No, unit 2, lesson 4 practice. Let's get right to it. The warm-up wants us to find each quotient. Quotient is just it's a word that means division. A really basic way of thinking about it is it's the answer you get when you do a division problem, but sometimes people also use it to just mean the division itself, or even like a verb to divide would be to quotient. That's pretty rare for people to use a word that way though, but it just means divide. Um, so this first one, we got 640 divided by 100. It's not going to come out to a nice whole number, but we can use a trick when you're dividing by 10 or 100 or 1,000 or 10,000, any number that's just a 1 followed by a bunch of zeros, then you're really just moving the decimal, because decimal, DEC, means 10. Our whole number system is based on tens. We count to 10 and then we move over 10 again, and we move over. The whole thing's based on tens. It's a 10-based system. So let's just move the decimal. There's an invisible decimal right here at the end of 640, right? Technically, it's like 640.0, if you wanted to think of it that way. Now, when we divide it by 10, that makes everything 10 times smaller, and it would move that decimal point over here to be between the 4 and the 0. The answer would be 64. When we divide by 100, we just do it one more time. And now that decimal point is sitting between the 6 and the 4, making the answer 6.4. Now, I know it would be tempting to grab a calculator, your phone, whatever. I've got mine right here. I could start punching stuff in to do all these. But there's a pattern here that they want you to see. And when we're working with proportional relationships, and especially ratio tables that often have a pattern to them, your ability to recognize patterns, pattern recognition, as we call it, is really important and really useful, not only just in math, but in life. And so I want you to try doing these questions thinking about patterns and relationships. The first number in the next question, which is called the dividend, the thing being divided is the dividend, is the same as the one in the first question. But the divisor, the divider, the one doing the dividing, called the divisor, is only half as big. So if you take the same thing and you divide it into half as many pieces, then those pieces should wind up being twice as big, right? If you've got a pizza with 12 slices and you divide it among 4 people, or you divide it among 2 people, the pizza that gets divided among 2 people, those people are going to get twice as much pizza as the one with 4 people, right? So it's the same thing that's happening here. The answer is going to be twice as big. Same number divided by something half as big gives you an answer that is twice as big. And so I'm just going to take this right here and double it. 6 times 2 is 12. 4 times 2 is 8. I got a 12.8. Now look, same thing in the next one. The dividend is the same number, 640, but the divisor is half as big as this 50. So what is that going to do to your quotient, the answer? All right, so I'm going to leave that one for you to get. And now look at the last one. The last one, the divisors are the same, but the dividends the new one is 10 times smaller. You have 10 times as less stuff to work with, right? You got 64 instead of 640, like 10 times as less candy or 10 times less money to share between people. But it's the same number of people getting it, right? It's still 25 people. So everybody's just going to get 10 times less. So whatever your answer was for here, your answer to this one should come out 10 times less, or 1/10. Move the decimal. That's all you got to do. All right, let's move on. It says each table represents a proportional relationship. Okay, so we don't have to check for proportionality. We are being told that these are proportional relationships. For each table, find the constant of proportionality, aka our K. So I'm going to write this over here. K equals Y divided by X. Remember, a fraction bar means division. This is one of the equations that lives on the wall in my classroom, on the upper left part of the board. This is up there. It says the constant of proportionality always equals a y value divided by an x value in a proportional relationship, okay? And then it says write an equation that represents a relationship, okay? So that's going to require that other equation that's up on the board in my classroom, up on the upper right, like kind of above where I always stand, the one that looks like this. Y equals K X. It's just the same pieces, but like rearranged. And they're both supposed to remind you of certain stuff that you do a lot in my class. This one's supposed to remind you how to get your constant of proportionality. Just do a y divided by x. All right, cool. Let's do y divided by x. We have s and p, not x and y. So this says y and x because y and x are the letters that we use most frequently. Sometimes we use s and p or a and b or whatever. You just got to remember which one's which, and you'll be all right. You can still do the same thing. If we have no other information telling us which letter is which, then it's pretty much always safe to assume that the first one is X, right? S is like X this time, and P will be like Y. And so, like, we're going to do a Y divided by X, but I guess in this case, it's going to be P divided by S, same thing. So, and it doesn't matter which one you do, because we know it's proportional. So pick your favorite. Do 8 divided by 2, 12 divided by 3, 20 divided by 5. They should all come out to the same thing. 8 divided by 2 equals, I hope you're able to do that. Okay, and so now that's sort of like your step one. Whenever you're trying to build an equation, do that first. Get your K by doing a Y divided by an X or a P divided by an S, whatever. Then step two is to just literally copy this, except the only thing you do different is that whatever answer you got for here, you no longer need the letter K because you know what K is now. K is a number. You figured it out. You got an answer. So you don't put the letter K there. But you still need the other letters because they help represent the whole relationship. We probably shouldn't use Y and X in this case, though. We should probably use the letters they gave us. So instead of where Y is in this thing, we're going to put P. Instead of K, we're going to put the answer that you got to this one, which by now I hope you realized is 4. 8 divided by 2 is 4. And then we're going to put our X. But let's not use X. They gave us an S in the table over here, so we use S. I prefer it if we stay away from using S's in our equations and our algebra as much as possible, because they look kind of like 5s, right? Like if you don't make it really nice and squiggly like an S should be, if you're kind of lazy with it, then that could accidentally look like P equals 45. We don't want that. Check your handwriting. Does yours look like P equals 45? Fix it. All right. So let's do the same thing over here. Oh, so I'm going to put a 2 here. Is this like step 2, right? So step 1, same thing here. Let's do Y divided by X. Again, this time we got D and C, but we'll think of this side as the Y side. We'll think of this side as the X side. Pick any of these pairs. It doesn't matter. You could do 9.42 divided by 3, 15.7 divided by 5. They should all come out to the same number. And because I know they come out to the same number, I'm going to pick the one that I think is easiest, which is actually the last one. Because I know that when you divide by 10, you just move the decimal point. Oh, well, wait. We're not going to divide by 10. I'm going to divide by the 31.4. Okay, so I guess I'll do the top one then. No, wait, we are going to divide by 10. I confused myself for a second. I got backwards. Yeah, I'm going to do 31.4 y divided by 10 is x. Okay, see, it happens to everybody. So if you ever mess up doing an x divided by y instead of a y divided by x, you've probably already seen me do it in the classroom before too. We're all human. All right, so I know that dividing by 10 just takes this decimal point and scoots it over one spot, right? We were just talking about that in the warm-up. And so instead of 31.4, we get 3.14. I think they're talking about kind of a special number here. I think this C is supposed to represent circumference, and I think this D is supposed to represent diameter. And I think this number right here is something special that we'll be talking a lot about in March if you're not already pretty familiar with it. All right, so let's make our equation. Oh, I'm just not realizing they already put the letter here. It already says P equals, and then I put P equals. Okay, so I guess this time we don't need to do that. C equals, so we already got the first part. That's our Y equals, C is Y. You don't write the letter K, you write 3.14. Oops, I forgot the 1. Geez, I'm making all sorts of mistakes here. And then don't use X, right? This time it's D. So The circumference of a circle equals 3.14 times its diameter. That's what they're getting out there. We'll talk more about that later this year if you don't already know how to do it. All right, next it says a plane flew at a constant speed. Constant speed is really just another way that we talk about proportional relationships. If something is a constant speed or a constant rate, then that's going to be proportional. Well, as long as we're dealing with linear stuff, I guess you could have some. Can you have constant exponentiality? I don't know. For us in 7th grade, it means proportional. So let's see, it says complete the table. Okay. We should probably find our constant of proportionality. This is pretty much always a good first move. When you're dealing with proportional relationship stuff, if you got a y and an x, divide them and get that constant of proportionality. So we've got, in this case, we've got, I guess, h for hours and m for miles, or t for time, d for distance, whatever you want to say. But we could think of this as our x side, and this is our y side. And so let's do y divided by x and get our constant of proportionality, which is essentially going to be the plane's speed in this case, right? I guess I'll get the calculator out for this one. I don't feel like doing, was it 915 divided by 1.5? I got it just off screen because I want you to be doing it. Like, I know you probably have your phone with you too, or whatever. You punch it in before I punch it in so that you can see if you got the same thing as me. All right, let's see. I got 610. You probably got the same thing. So that means if the plane's flying at a constant speed of 610 miles an hour. And so if we know how many hours it's flying for, we're just going to take that and multiply by 610. I use an X to mean multiply there, but really we should get used to using dots to mean multiplication. And that's going to get us the distance, right? If you know how fast something's going, you know how long it's going that speed, multiply them, you'll get how far it's going. This is kind of an important equation that you need actually. So we're going to do 1 times 610 equals, that one's easy, 610, right? 2 times 610 equals, that's going to be your answer there. 2.5 times 610. I'm going to leave those for you to fill in. You can get those. Now, last one, they just give us t. We have to take t and multiply it by 610. Well, you can't really do that. You can't times a t by 610, but you can express it. You can write it. You can say, well, I don't know what it is, but whatever it is, it's 610 t. 610 times t, whatever. Okay, that's called an expression. So we express stuff. All right. How far does the plane fly in 1 hour? Well, we got it right there in our table. So there you go. How far would the plane fly in t hours at this speed? Again, we don't know because we don't know what t is, but we can express our answer. We can say, well, whatever it is, it'd be 610 times t. When I put that t next to that number with nothing in between it, I'm saying 610 times t. Now you could put a dot there, but nobody does it. You don't need it. All right, next it says, if d represents the distance that the plane flies at this speed for t hours, write an equation that relates d and t. This is that thing I was just talking about 30 seconds ago or whatever, and a very important equation that you need for not just this math class, but like science class, physics class, when you take one of those someday, and life, really. If you want to know the distance that something goes, if it's going a constant speed the whole time, then take that speed, which we could use S for speed, but like I just said, I don't like using S. So I'm going to use R for rate. Same thing, right? It's rate of speed, I guess you could say, times its time. And I could put dot T for times, but you don't need it. If you just put a letter next to anything with nothing in between, it means multiplication. So the distance something goes is equal to its rate times its time. All right, so how far would the plane fly in 10 hours at this speed? Show your reasoning. That's just another way of saying show your work. Okay, take its speed, multiply it by 10. You got that. You know, if I'm going a little fast for you whenever I'm doing this, like you can, right, you can pause the video real quick and do 610 times 10 to get an answer on that next one, and then keep playing it, right? All right, so we're on the next page here, or if you're doing it online, then you're on the next screen, whatever. It says, let's fix this a little bit. Nathan is planning to ride his bike for 24 minutes. If he rides his if he rides at a rate of 3 miles per hour, that's an extremely slow rate to ride a bike. Like that's almost like so slow that you're like gonna fall over. How far will he travel? Okay. Well, they're trying to throw us a little bit of a curveball here because our rate is in miles per hour. Now, if we want to multiply that by a time to get a distance using that thing we were just talking about, distance equals rate times time, all the units have to match up. You can't take miles per hour and times it by minutes and expect it to get something right, because we can't do 3 times 24 and then say, oh, he's going to go 72 miles. Like, nah, he's not going to get 72 miles going that slow in 24 minutes. So we got to turn this 24 into hours, this 24 minutes into hours, like some fraction of an hour, or we got to turn this 3 miles per hour into how many miles per minute. And I feel like that would be the weirder way to do it. So we're going to turn 24 minutes into hours. And it's just divided by 60 because there are 60 minutes in an hour. So if we do 24 divided by 60, we'll get just how many hours 24 minutes is, right? It should be a little less than half because 30 minutes is half in an hour. So let's see here. We could do it fractions, but I don't know. How about let's make our lives easy this time. Let's do decimals. I think will come up. Okay, so let's do 24 divided by 60. We should get like 0.4 or something. Yeah, 0.4. Okay, so it's 0.4 of an hour, or 4/10 of an hour is 24 minutes. So that's what we really need. Is we're gonna just kind of put a little note here that 24 minutes is 0.4 hours. Now we can multiply. Now we can just take 3. Okay, so this was like a step 1 here. This isn't the answer. The answer is not 0.4. Okay, step 2 is 3 miles per hour times 0.4. Now I'm going to put that 0.4 in parentheses just because I don't like having a times dot and a decimal dot right next to each other with nothing separate them. It looks weird. Multiply those, get an answer. And then that's going to be in miles. Okay, now if he rides at a rate of 5 miles per hour, how far will he travel? That's just going to be the same thing, right? Except one number will be different. We already know, like they didn't change the time. So we already know he's going to ride for 0.4 hours. But on this one, instead of multiplying by 3 for 3 miles an hour, just multiply by 5 for 5 miles an hour. I decided to go parentheses again this time. So when you put 2 numbers next to each other and one's in parentheses, but there's nothing else, there's no plus signs and minus signs or anything, that also means multiply. So multiply those and you should get a distance, miles, how far he'll go. Okay, and so this one says, write an equation that Nathan could use to find the distance d. He will travel in 24 minutes with any rate in miles per hour. Okay, so let's think about what we did in both of these questions. In both of these questions, we took his rate. In this one, it was 3, and in this one, it was 5. And we multiplied it by his time, which in both cases was 0.4. Now, this one, they're saying his distance will always, or sorry, his time will always be 24 minutes. That's not going to change. Okay, but we're going to use 0.4 for our hours, not minutes. We're always going to multiply that by his rate, which could change. Maybe he's going 3 miles an hour, maybe he's going 5, maybe he's going 10, whatever. But whatever it is, it'll be R. That's kind of an ugly R, looks like a V. That's an R. And that's always going to equal his distance. Okay? 0.4 hours times his rate equals his distance. All right. I should have been saying so far in class, the rule that I usually use every year on the explore sections is you have to at least try them. I will not take away like your full credit if you're not able to like finish it or solve it, but I will if you leave it entirely blank. You got to show me that you tried something, took a couple of guesses or whatever. Okay, so give this a shot. What does it say? Here are 8 columns. Pair up the columns such that each pair creates a table that represents a proportional relationship. Okay, so we want to make pairs so that they're proportional. All right, so I look at A and B. A and B can't be a pair because 1 times 9 is 9, but 2 times 9 is not 27. So there's no like constant ratio between those columns there, so it can't be that. If I try A and C, 1 times 8 is 8. 2 times 8 is not 12. So it can't be A and C. All right, let's try A and D. 1 times 2 is 2. Oh, wait, but this first one can't be 1. This one's got a 0 in the first spot. 0 times nothing equals 1. You can't do that. So it can't be A and D. All right, let's try A and E. Same thing. E has the same problem, having that 1 there. In fact, that probably tells me D and E are going to go together. I don't know that for sure, but maybe. Actually, nope. Now that I look at down here, D and E aren't going to go together. Okay, let's try A and F. All right, we got 0 and 0. 1 times 1 is 1. 2 times 1 is not 3, so it can't be A and F. All right, we're getting down to the nitty gritty here. All right, A and G. 1 times 7 is 7. 2 times 7 is 14. 4 times 7 is 28. Okay, so I think A and G are going to go together. So maybe I'll like draw something to connect them. But then you got to fill in the blanks. You got to say what needs to go here so that they stay proportional and what needs to go here so that they stay proportional. Okay, so see if you can make 2 more pairs out of the other ones that are remaining. And then there should be one that's like left over, but that one goes with H. And H, you fill in entirely yourself to make it proportional with the one that got left over. All right, see you next time.